I am Dr. A. Prasanna, working as Assistant Professor in the Department of Chemistry, V.V. Vaniyaperumal College for Women, Virudhunagar. In this video, we are going to see Markovnikov and anti-Markovnikov's rule. In the last video, we have seen the types of organic reactions, which includes addition reaction. So, I am going to continue that addition reaction. Here, this Markovnikov rule applies. It is applicable in the case of addition of HBr to alkene. Okay, let me recall what is addition reaction. Addition reaction is the reaction which involves the addition of two reactants resulting in larger product. So, the chemical compounds which possesses multiple bonds will undergo addition reaction. So, addition of HBr to alkene is an example for addition reaction. So, here this alkene reacts with HCl to form alkyl halide. So, this is an example for addition reaction. In this case, this is a symmetrical alkene. Markovnikov rule is applicable in the case of addition of HBr to unsymmetrical alkene. In the case of symmetrical alkene, we are expecting a single product. So, that is, in the first case, we have taken ethene. HBr adds on to ethene, and here alkyl halide, that is ethyl bromide, is obtained. So, this is only the product when this HBr adds on to ethylene. Also, in this case, that is 2-butene. 2-butene, it is also a symmetrical alkene. Here also HBr adds on to this 2-butene and forms a single product, that is 2-bromo-butane. But in the case of unsymmetrical alkene, that is propene. What is unsymmetrical alkene? Here, look at this carbon-carbon double bond on either side, on either carbon atoms, dissimilar groups are attached. So, this is unsymmetrical alkene. Okay, so this addition of HBr to unsymmetrical alkene like propene, it leads to the formation of the two products, product 1, that is 2-bromopropane, and product 2, 1-bromopropane. Among these two, one is formed predominantly, and this predominant product is desired, that is told by this Markovnikov rule. Let me point out what is Markovnikov's rule. Actually, this rule states that the negative part of the addendum adds on to the carbon containing lesser number of hydrogen. One more time I will repeat. The negative part of the addendum adds on to the carbon containing lesser number of hydrogen. That is, look at this HBr. How does it ionize? H plus and Br minus. Here, this Br minus is the negative addendum. This Br minus adds on to the carbon containing lesser number of hydrogen. Here, CC double bond, which has 2 hydrogen atoms. This is the carbon atom with 1 hydrogen atom. So, the negative part Br minus attacks this carbon containing 1 hydrogen atom. So, among these two products, 2-bromopropane is the predominant product. 1-bromopropane is minor product. This 2-bromopropane formation is mainly confirmed to the mechanism. This is arrived through the mechanism. What is mechanism? The actual pathway of the reaction. The formation of the 2-bromopropane is ascertained through its mechanism. So, let me point out the mechanism here. In the first step, H plus, actually this is electrophilic addition reaction. So, electrophile attacks, H plus attacks the propene, leading to the formation of carbocation. So, what is carbocation? This is the positively charged carbon atom. Okay, so this H plus can attack either of the carbon 1 or the carbon 2. If it attacks the carbon 1, it forms, if it attacks the carbon 1, it forms a more stable secondary carbocation. If this H plus attacks the second carbon atom, then it leads to less stable primary carbocation. Okay, so look at this. This is the primary carbocation. So primary carbocation is less stable. This is the secondary carbocation, carbon C plus, which has on both sides methyl groups. So carbon with the positive charge is in turn attached to two different carbon atoms, that is secondary carbocation. So this is the more stable carbocation. The reaction which proceeds through the more stable carbocation is it leads to the major product. In the second step, the more stable carbocation, that is the secondary carbocation formed at that site, Br minus attacks, leading to the formation of 2-bromopropane. So that is the major product here. So next let me point out anti-Markovnikov's rule. If this addition reaction of HBr on the unsymmetrical alkene takes place in presence of peroxide, the addition is reversed. That is, it's just opposite to that of the Markovnikov's rule. That is, the negative part of the addendum adds on to the carbon with more number of hydrogen. This is the statement for the anti-Markovnikov rule. This rule is also known as the peroxide effect. Here is the equation which represents this. This is unsymmetrical alkene. HBr adds on to this unsymmetrical alkene in presence of benzoyl peroxide. Okay, so here the 1-bromopropane, this product is formed predominantly. This is the major product. So this product formation is ascertained through its mechanism. So in the first step, benzoyl peroxide undergoes homolysis and leads to that is phenyl radical. This phenyl radical then reacts with HBr, forming this bromide free radical. This bromine free radical. This bromine free radical is the initiator for the next step. So this bromine free radical attacks propene, leading to two different products. One is less stable primary free radical, another one is more stable secondary free radical. These two possibilities are there here. Among these two, this more stable secondary free radical is the major product that leads to the major product here. So this is the more stable secondary free radical. This that is carbon with the one odd electron, that is said to be free radical. This anti-Markovnikov rule is applicable in presence of peroxide. In the peroxide, here free radical mechanism is operating. So here this secondary free radical formed that attacks HBr. Upon that secondary free radical, HBr attacks and leads to the major product, that is 1-bromopropane. So the primary free radical, it can also react with HBr and forms 2-bromopropane, that will be the minor product, because this primary free radical is less stable. So this leads to the formation of the product to lesser extent. Let me summarize. Markovnikov's and anti-Markovnikov's rule predict the major product formed when hydrogen bromide adds on to unsymmetrical alkene. If it is a symmetrical alkene, only one product is expected, but if HBr adds on to unsymmetrical alkene, two products are expected, among these two, the predominant or major product can be predicted by using this Markovnikov's and anti-Markovnikov's rule. The formation of the stable intermediate. In the case of Markovnikov's rule, the stable intermediate, that is secondary carbocation, that decides the major product. But in the case of anti-Markovnikov's rule, the formation of the secondary free radical, that decides the formation of the major product. So at the outset we can say the formation of the stable intermediate during the course of the reaction decides the major product in both the cases. That is addition reaction, addition of HBr on unsymmetrical alkene. So we can apply this addition reaction to any unsymmetrical alkenes. We can predict the major product. With this I finish this video. Let us see in the next video. Thank you.